Greetings, everyone. Welcome to today's video. I'm Clifford Mwenda, a GMAT trainer with the Kenya Elite program. And as you've seen, today we'll be doing sequences and basically using logical reasoning behind these topic sequences. And so without much further ado, let's jump into the video. First, I would like to introduce the data sufficiency question format once more, and especially the answer choices that you need to have on your fingertips. The statement 1 is alone is sufficient for A, B is 2 alone is sufficient, for C both 1 and 2 together are sufficient, and D each statement alone is sufficient to answer the question, and E statements 1 and 2 together are not sufficient to answer this question. And so I'll be showing these answer choices each and every data sufficiency question so that you don't find it difficult for all those starting GMAT studies of late. All right, let's know what we need to know first before doing sequences. And so we need to know number theory concepts, for instance, number types and properties, the definitions of what is consecutive, what is even, what's odd, what's an integer, what are exponents. All these are concepts you need to be familiar with before doing sequences, so you don't have a difficult time understanding sequences. You also have to know a basic math, addition, subtraction, division, multiplication, and how these number theory concepts and basic math features well in sequences. We also need to know the properties of these concepts in number theory, that is the number types and their properties, how consecutive integers behave, how even integers or even numbers, that's integers as well, behave, the odd numbers, how do they behave, the exponents, how do they behave, and so on and so forth. And so the other thing that you need to know before doing sequences is how to interpret word problems using algebra and solving 2 or 3 simultaneous equations. And lastly, inclusive counting. And how do we do that? We can have this example here. How many multiples of 10 are there from 200 to 750? Now, let's talk about sequences before we do actually do some practice questions here and there. So sequences are ordered list of numbers. We can have 1, 2, 3, 4. These are consecutive integers. These are sequence, right? And commonly denoted as AN, this is the nth term in a sequence, right? So AN, this is the nth term in a certain sequence. If you have A1, this is the first term of that sequence. AN is the mostly denoted as the last term in the sequence. And then what do we need to know about sequences and their properties? We have different types of sequences. Therefore, they are arithmetic sequence, geometric sequence, harmonic sequence, and you also have the terms recursive sequence. Sorry about that. So all these sequences are good to note, the formulas, but you need to have that right brain thinking where you have to know the logical reasoning behind these sequences. It's good to have the formulas, and it can constitute about 10% of what you do in the GMAT, but you need to understand behind deeply how these sequences are structured and how they're built. So for geometric, I'll just mention briefly, arithmetic sequences where you have a common difference between our values. We have, say, the first term is 2, then you have a difference of 2, that's 4, a difference of 2, that's 6. These are consecutive multiples of 2, so this is arithmetic sequence. You can also have 3 and a difference of 5. You have 8, a difference of 5 here. You have, that should be 13, 5, 18, and so on and so forth. For the geometric, this is where you have numbers multiplied together, and therefore you'll have, for example, the first term is 2, the second term is multiplied by 3, that should be 6, the third term multiplied by 3, that should be 18. That's how a geometric sequence is built. So this is arithmetic sequence, this is geometric sequence. We have, this is the first, this is the second, this is the third. And then we have harmonic sequence. This is the reciprocals of the values of arithmetic sequence. So we'll have, in this case, a third, an eighth, 1 over 13, 1 over 18th, and so on. Recursive sequence are not related to arithmetic, geometric, and harmonic sequences. These are sequences that a term is expressed as a previous term. For example, 18 is expressed in terms of 13, 13 is expressed in terms of 8, and so on and so forth. So these are types of sequences and the properties, you need to know them. You can go through all the materials that you have and actually understand what these are. If not, you can the GMAT will give you at least 2 values and the sequence will be specified, and then you can systematically find the values asked about in the question. And this will be using the logical reasoning from the title of the video, right? Now, I'll also need to identify quick patterns and be attentive to the right details to ask these questions. For example, what is the sum of multiples of 10 from 200 to 750? Pause the video, give it a try, then I'll jump in and see how this question is calculated. All right, a famous mathematician, I don't know by the name, but he was asked to count or add all the values from 1 to 100 within a time frame, and he actually did the question less than a minute. What he observed is a pattern where you have 1 plus 100, that's 101. I use this pattern to tackle another question in simple and compound interest. Even if you're not familiar with the pattern, go to the video on simple and compound interest and watch it once more. So you also have 2 plus deduct it by 1, you have 99, that's 101. 3 plus 98, this is 101. 4 plus 97, this is 101. As you can see, there's a pattern. So from 1 to 100, we'll have about 50 pairs of this, right? 50 pairs times 101, and you'll have the total as 505, and that's a 0. Is the addition of values from 1 to 100. So we'll use the same approach to tackle this question.
You're watching Success with Bob Mwiti Show, presented to you by Upstack America. Upstack America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstackamerica.com. Upstack America, we wake you up to the unlimited potential.
Now, let's give some questions a try. Here's the first question. If M is a set of consecutive even integers, is 0 in the set M? -6 is in the set M, -2 is in the set M. Give it a try. Pause the video and give it a try. So, if M is a set of consecutive integers, is 0 in the set M, right? -6 is in the set M. If M has, say, 3 consecutive integers, can have even consecutive integers, can have -6, -4, and -2. Is 0 in there? No. What if there are, say, 4 consecutive integers or 5 consecutive integers? Will have -6, -4, -2, 0. Is 0 in the set? Yes. So we have no, we have yes, no consistent, yes, no consistent, no. Since this is a yes, no question, and therefore statement 1 is not sufficient. If statement 1 is not sufficient, we take out A and D. Now we're left with B, C, and E. -2 is in the set M. All right. In this case, if you're to take -6, -4, -2, the same set will have, is 0 in the set? No. Let's take this one. -2 is also in the set. Can have -6, -4, -2, 0. Is 0 in the set? Yes. Same, have not sufficient, and therefore B is also out. If you combine the statements, there's no new information since both -6 and -2 are in the sets, and therefore C is also out, and it'll have our answer as E. Right, that was a sub 500 question. This means that most test takers did that question and got it right. Right, here's a more difficult question. Give it a try. If any sequence of n non-zero numbers, a pair of consecutive terms with opposite signs represent a sign change. For example, the sequence -2, 3, -4, 5 has 3 sign changes. That's -2 to 3, that's 1. 3 to -4, that's 2. -4 to 5, that's 3. Those are 3 sign changes. Does the sequence of non-zero numbers S1, S2, S3, all the way to Sn have an even number of sign changes? Yes or no? Here's a right way to approach this question. So we have sk equals to -1 to power k for all positive integers k from 1 to n. Now, let's have different, say, sequences. So we'll have the first sequence with 3 entries. So they can have the S1 as -1 to power 1. This is -1. Then we have S2 as -1 to squared. This is 1. And S3 as -1 to power 3. This is -1. And S4, let's give that's -1 to power 4. This is 1. So we have, if you have a 3 consecutive integer, 3 consecutive or not 3 numbers in the sequences, S1, S2, S3, then you'll have S1, S2, S3 as -1, 1, -1. How many sign changes are there? These are 1 and 2, 2 sign changes. All right, that's an even number. What if we took S1, S2, S3, S4? That should be -1, 1, -1, 1. So how many sign changes? These are 1, 2, 3 sign changes. That's an odd number. So we don't have the value of n, and the value of n is really needed so that you can have to determine if it's odd or even for the number of sign changes. And therefore statement 1 is not sufficient. A is out and D is out. Now we have n equals 2 odd. And how can this help? Right, since that's only what we know that S1, S2, S3, all the way to Sn, we have n equals to odd. We don't have the actual formation or the sequence itself. This is also not sufficient, and we'll have B out. Let's combine this. So we have the sequence, we also have n as odd. If you had to take S5, we'll have -1 to power 5. This is -1. So how many sign changes will there be for S1, S2, S3, S4, S5? We have -1, 1, -1, 1, then -1, 1 change, second, third, and fourth, so forth. Even number. For every odd number of numbers in the sequences, we'll have even number of sign changes. And therefore, combined, these two statements are sufficient. And therefore, we'll have C as the answer and E as out. We'll have C as the answer to this question. All right, here's another question. Please give it a try and then I'll jump in. Sorry about that. So a sequence of numbers A1, A2, A3 is defined as follows. A1 equals to 3, A2 is equals to 5, and every term in the sequence after A2 is the product of all terms in the sequence preceding it. For example, A3 equals to A1 times A2, A4 equals to A1 times A2 times A3, and AN equals to T, where N is greater than 2. What's the value of AN plus 2? Right, so let's see if there's a pattern here. So we have A1, this is a problem solving question. This equals to 3, A2 equals to 5, A3 should be 5 times 3. Yeah, 5 times 3, this is 15. And then you'll have A4 as the multiplication of all those, 15 times 3 times 5. This should be 15 squared, since this is 15. So we'll have all this multiplied together. Let's let's write this. So this is 15, this is 15, and this is 15 squared. So we have 15 squared times this A3, that's 15, times 8, 1 times 8, this is 15. So we'll have 15 to the power of, this is 1 to the power of 4. That's A5. A6 equals to 15 to the power of 4 times 15 to the power of 2 times 15 times the other 15. This should be, this is squared. So this is 1, this is 1, this is 2, 3, 4, 8. As you see, this is 15, this is 15 for the first 3 terms, 3, 5, 15, then 15 squared. The power of this from A3 to F4, the power is multiplied by 2. So you can have from 15 to power 1 to 15 squared, then multiplied by 2 again, that's 15 to power 4, then multiplied by 2 again, that's 15 to power 8. And if you're to find 87, we need it as 15 to power 16. We can try that. So 15 to power 8, 15 to power 4, 15 squared, 115, and the other 15. This should be 1, 1, 2, 3, 4, 2, 3, 4, 8 plus 8, that's 16. And as you can see, that's the pattern here. So we need to find the value of an plus 2. So since we know that an is equals to t, then an plus 1 should be the power of this multiplied by 2. This is 2 squared. And an plus 2, the power of 2 multiplied by 2, this is 2 to power 4. And D should be our answer. With attention to the right detail, you can get these questions right with this pattern recognition skill that I mentioned about. All right, as you can see, sequences is not a very hard topic. It's a very logic-based questions, and you need to be prepared for these sequences questions and give them a lot of practice, find those patterns, find those pitfalls in each and every sequence question that we'll be doing. And therefore, thank you for coming today. Thank you for watching the video. Please like, subscribe, and share. I've been Clifford Mwenda, GMAT trainer with the Kenya Leaf program. Until our next video, bye-bye.